All right, welcome to this quick session about using CyberArk's Dynamic Privileged Access to connect to a Kubernetes cluster to perform some sort of administration, maintenance, or just general tasks against the cluster itself. Now, before we jump into how the end user actually makes the connection, I want to talk a little bit about the um, permissions and how do you allocate or grant someone access to make the connection. And for those of you familiar with our privileged cloud or our self-hosted vaulting solution, this will be very simple. Basically, within CyberArk's privileged cloud capability, what you would do is vault the credential. In this case, that will be the certificate chain for the Kubernetes cluster in a specific safe, and then grant users access to that safe. So very similar to how you would grant someone access to, say, this Ubuntu account to access a Linux system, you can grant them access to a specific role or credential for a Kubernetes cluster by vaulting that credential into a safe and granting them access to the safe. So in this case, I'm logged in as myself, Joe Strickland. I can see that I have this safe, Pineapple Infrastructure DPA Kubernetes. I have access to the safe. I can actually interact with the safe. And I have two separate clusters vaulted. In this case, K8s and a vanilla Kubernetes cluster. Both are actually running in AWS on EC2 infrastructure. That doesn't really matter. But I just want to point out that my end user cannot access these directly because I don't have direct network connectivity. Now, how do I actually use them? That's the next question. First, we would switch over to Dynamic Privileged Access. I want to point out that you do not have to use this user interface, the web UI, if you don't want to. We're going to show that next, but I do want to show this because it might give a better understanding for the end user. For brand new users, they would switch over to Connection Guidance, and then they would choose Kubernetes. Now, this gives you an idea of what happens whenever I hit this generate and download button. What is occurring is we are generating a kubeconfig file that is going to contain a list of all of the clusters I can connect to, as well as a certificate that is used to connect me to the DPA service or CyberArk's DPA SaaS connection point. Now, the certificate used for authentication is only valid for a specific set of time, and that is controlled based on settings that you as an administrator can configure. By default, I think it's 120 minutes or 2 hours, but you could change that to 30 minutes, 8 hours, 4 hours, whatever you would like within reason, right? We're not going to let that certificate be valid for 5 days, for example. Now, if the certificate expires, I have two options. One, I can come here and regenerate the kubeconfig file. This would be useful if, for instance, new clusters were added into the Privileged Cloud Vault, or if I just need a new certificate. Alternatively, as an end user, I can come to MFA caching, choose Kubernetes, and I can generate just the new certificate and new key that I need to update my kubeconfig file with. Now, as I mentioned, most Kubernetes folks are probably not going to want to come into this web UI. The good news is you do not have to, right? You can open up your terminal of choice. In this case, I'm using iterm2, and utilize our Ark CLI to establish this connectivity. Now, the first step you would typically perform is Ark login. If you haven't logged in the last 2 hours or so, or whatever your administrator has this configured to be from a limit, you would be prompted to go through all of the MFA. Now, in my case, I'm already logged in, so I do not have to re-authenticate. After I have done this, basically, I would just run a single command to generate a new kubeconfig and put that into the appropriate directory. In this case, my home directory .kube. And when I run this command, we're basically calling all of the API calls to do exactly what I did within the web user interface and importing that file directly to the appropriate location. If I take a look at that location right now, you can see that this config file was updated at 201 and it is 201.49 currently. So we've updated this config file and it is now usable by my user to connect to a target system or a target cluster. Now, I can easily actually look at that file if I want. So I could do a VI and look at the file itself. And inside of the file, we're going to see a couple of different things, right? We see some certificate authority data. We see the two clusters that I actually have connectivity to. So the vanilla Kubernetes cluster as well as the K3s cluster. And then we see this important stuff here. This is the certificate data that is going to allow me to connect to the DPA service. This is the cert, and then the key that is going to broker that connectivity. Again, this is only valid for a certain period of time. So be aware, it's only valid for that 1 hour or 2 hours. It's also only valid from the WAN address that it was requested from. So if you try to use this from a machine that's on a different WAN or has a different WAN IP, this client cert and key will not work to authenticate you to the DPA service. Now, I'm just going to exit out of this, and we'll actually make a connection and do something like get namespace, right? Now, what I'm doing here, it takes a few seconds to establish the initial connectivity to our DPA service. Once this is established, we do form kind of a stateful connection so that any further commands that I run against the Kubernetes cluster are going to be much quicker. Now, those of you familiar with kubectl will say, well, kubectl is kind of a stateless command. It runs on demand. That is true. In this scenario, since we're using dynamic privileged access to broker or act as the bastion for this capability, we are kind of establishing a slightly stateful connection so that future commands, like let's say I run get pods here, will be much quicker, right? Get containers, or as another example. I don't have any containers deployed. But the point is, the initial connection takes a few moments just to establish that stateful connection, validate my authentication, broker the connectivity to the target. After that, every command should run pretty much as expected, as if you were natively connected directly to the cluster. So from an end user point of view, really all they would do is 3 steps. Log in using Arc CLI, generate a new kubeconfig. They may have an optional step of doing something like kubectl config and then specify the exact context they want to use. That is, if they have several clusters available. After that, they can start running the various commands that they need to run. Pretty cool, pretty powerful, and it's great because now I don't need that actual private key, that cert chain on my end user system. I just use DPA. DPA retrieves that from the vault as long as my user has access and connects me to that target. Now, I want to quickly show you a little bit about the audit that's available. So if I come over here and I go to the audit service and go into session monitoring, we will be picking up all of these actions, right? So this was a session I ran a moment ago. Let's take a look at this one first. And we can see the session details tell me exactly which user, myself, Joe Strickland, what my target was, that I was using a vaulted Kubernetes account, and that I ran specific commands. So if I come over to commands, it's going to walk you through the commands that were ran. Now these are translated into the API commands that kubectl is actually running, right? So get nodes, get namespace, etc. But if I had run several different commands, they would all show up within this command list, and I can now perform whatever auditing I need, and I know exactly what user was using that kind of built-in role to perform those actions. Overall, I think it's a pretty powerful capability. Obviously some users could be granted access to kind of a read-only type of role / user. Some could be granted access to a full administrator of the cluster. You could do that based on safe permissions. So if you're already managing access to infrastructure that way, it becomes very simple to expand that and grant your developers, your Kubernetes admins, native access through their terminal directly to those target systems. I hope you enjoyed the session. I hope it was informative. If there are any questions, put them in chat. Like and subscribe, and look forward to presenting more for you in the future. Thanks. Bye.